This is the last video that is going to revise the last part of the organic. There is little bit of alcohol phenol ether and alcohol phenol ether and the carbonyl groups. That means aldehyde ketone and carboxylic acid. So first question is suppose phenol is treated with the carbon tetrachloride. So phenol is treated with the carbon tetrachloride. So it will be phenol. It is better without showing the mechanism. So the state equation. So there will be less chances of mistake. If you do minus NaCl, that means if you show the which is liberating in each and every step, it is quite difficult for you to remember. So it is best to write the straight equation. There are two questions can be asked from here. One, phenol is treated with chloroform or phenol is treated with carbon tetrachloride. If the phenol is treated with the chloroform, that is Riemann-Tiemann reaction. This is the reaction. Phenol, chloroform, NaOH. This is NaCl, water. That is the straight equation. But if they told phenol is treated with the carbon tetrachloride, so if this tetrachloride is there, so it will be phenol, CCl4 plus 4 NaOH, 60 degrees centigrade, then it will be salicylic acid will be formed, OH, COOH, 4 NaCl plus 2H2. It is a straight equation. Okay, so phenol treated with chloroform in presence of NaOH, that will be Riemann-Tiemann reaction, and balanced equation is this one. Phenol, chloroform, 3 molecule of NaOH, then salicylaldehyde, then 3 NaCl, 2H. So this is phenol treated with chloroform in presence of NaOH. Suppose the question is phenol treated with carbon tetrachloride in presence of NaOH. So that will be the equation. Phenol, CCl4 plus 4 NaOH, 60 degree, then salicylic acid, then 4 NaCl and H2. Next, some questions. Rectified spirit cannot be converted into the absolute alcohol by simple distillation. Rectified spirit cannot be converted to the absolute alcohol by simple distillation. Why? Because they form azeotropic mixture or constant boiling mixture. That is why they cannot be converted totally into the by the simple distillation. Okay, so the answer is as they will form azeotropic mixture or constant boiling mixture. Diethyl ether does not react with sodium because they don't have active hydrogen. Ether means what? ROR. ROR means they do not have any active hydrogen. That is why they do not react to the sodium. Phenol do not undergo substitution reaction to the OH group like alcohol. So phenol do not undergo substitution because phenol OH group and the benzene, they undergo resonance, and that is why partial double bond character will form. So that is the structure. If you see that this is and the OH group is here, so OH group undergo resonance with the benzene ring, and due to that their OCO bond will be partial double bond character, and due to that reason it will not undergo substitution. So first one, why rectified spirit cannot be converted to the absolute, because they form azeotropic mixture, that means constant boiling mixture, that is why they cannot be converted. Diethyl ether do not react with sodium because they do not have any active hydrogen. Hydrogen is not there with the oxygen, that is why it cannot react. Third one, phenol do not undergo the substitution because due to the resonance, it will resonance of OH group and the benzene, they will form partial double bond character. That is why. We are moving to the next questions. Next question, some question this conversions. Okay, this conversion you can do your own also in the own way. I have done some in one way I have done. It can be done in the various way you can use it. Phenol to benzyl alcohol. Phenol is this one, benzyl alcohol is this one, benzene CH2OH. So you have to convert this one to this. That is why Zn dust is given. So it is converted to benzene. Then CH3ClLCl3. So this is a Friedel cap reaction. CH3 has come. Then you have given Cl2 by UV. Then one hydrogen is replaced by one chlorine. So this is CH2Cl, then aqueous NaOH you are giving. So it will OH has come. So it is phenol to benzyl alcohol. Next, phenol to aspirin, very very important. This is phenol to aspirin. Now, what we do phenol to aspirin? First we are taking phenol, giving NaOH. Water is eliminated out, so it will be ONA. Then we are using coal-based reaction. Carbon dioxide, 400 Kelvin, 4 to 7 atmospheric pressure. This is called coal-based reaction. Starting material is benzene with CONA. Then CO2, then 400 Kelvin, 4 to 7 atmospheric pressure you are giving. You cannot change anything, any of the condition. Then it will be OH will come, and in the side it will come OCOONA. Then if you give dilute HCl, so NaCl will go out, so it will be salicylic acid OH and COOH sidewise. Then if you give acidic anhydride, acidic anhydride if you give, last day if you have followed my video, I have shown you one part is will take it as a Cl, so it will be CH3CO OCOCH3, and we will take this part as a Cl. So this hydrogen and this Cl will be converted to form OCOCH3, and COOH will remain intact. So plus see that This part I have taken, this is the compound CH3CO OCO CH3 but I am taking Cl. From the OH group I have taken H and the Cl, so HCl is gone out. So this H and CH3COO converted to CH3COOH. So what is left? Here O is left and COCH3 is left. So OCOCH3 and COOH remain intact, that is called aspirin. So it is phenol to aspirin. First we are doing NaOH, ONA, cold base reaction, CO2 400 Kelvin 427, do not miss any condition. And then it will form OCOONA, then we are giving dilute HCl. So this Na and Cl, NaCl will go out. So it will be OH and COO salicylic acid, then acidic anhydride you are giving. So one part you are taking Cl. So this OH group hydrogen and Cl, HCl is going out. That means H and CH3COO. CH3COOH is going out. What is left? Here CH3CO left, here O left. So it will be OCOCH3 and COO. So it is aspirin. Next, cumene to phenol. This is also very important. Cumene to phenol. I have started with a little bit earlier because cumene is actually this. Okay, but I have shown you that how to prepare cumene. That is, you are taking benzene, then propene you are taking, then H3PO4 you are giving. So it is cumene formed. Okay, CH3CH is called cumene. Then if you give the oxygen O2 over here, it is a O2 if you add, then it will be hydrogen will be OOH. This O2 will be added over here in this carbon C and H. So it will be OOH. O2 is added over here. And then if you give dilute H2SO4, then benzene and this OH group. So it will form phenol and the remaining part is CH3COCH3. So remaining part CH3COCH3. So this is cumene, this is cumene to phenol. If they can be told benzene to phenol, you can do the in this way also. You can use the any other way also. If it's benzene to phenol, first you are using propene. Cumene has formed. Okay, CH3CH3, cumene has formed. Then if you give O2, O2 will be attached with the CH group. So it will be COOH. O2 is added over here. COOH. Then if you give dilute sulfuric acid, then benzene with the OH is phenol, and then remaining part is CH3COCH3. So CH3COCH3. So benzene and OH group phenol, and remaining part CH3COCH3. So this is CH3. So phenol to cumene to phenol. This is. Now we are moving to the another questions. Last question is benzene sulfonic acid to phenol. Next question is benzene sulfonic acid to phenol. So if you do the benzene sulfonic acid to phenol, if you see over here, this is benzene sulfonic acid, benzene SO3H. If you give NaOH into that, then what will happen? This Na and this OH. NaOH will go out as a water. So it will be SO3Na. Now you are giving 2 molecule of NaOH. Okay, if you give 2 molecule of NaOH, so it will, this SO3Na react with 1 molecule of NaOH from Na to SO3, that is going out. Okay, from another NaOH, one OH group will come over here, so it will form phenol. But as the medium is basic, that is why water will be eliminated, so it will be ONA. Again, I am telling SO3Na is there. You are giving 2 molecule of NaOH, so SO3Na is there, 2 molecule of NaOH, NaOH and NaOH, 2 molecule. So it is first react with the 1 molecule of, it will form SO3, Na2SO3, which is liberating. From the second molecule, first here OH will come. OH will come over here, and as because medium is basic, so from the OH, water will be eliminated out and it will form ONA. Then if you give dilute HCl, NaCl, Na and Cl, so it will be OH. So it will be benzene sulfonic acid to phenol. First you are giving NaOH, water will be eliminated, so it will be SO3Na. Then you are giving 2 molecule of NaOH into it. So first from 1 molecule SO3Na react together to form Na2SO3 will move out. From the another molecule OH will first come first, but that the medium is basic. After forming OH group over here, water will be eliminated out, it will be SO3, ONA it will be. And then dilute HCl, so it will be OH. Next, why is orthonitrophenol is more acidic than orthomethoxyphenol? You can see this is orthonitrophenol and orthomethoxyphenol, as the NO2 group has -I -R both effect, and my withdrawing effects increasing the acidity. So that is why as NO2 group has -I and -R both, that is why it is highest acidic. Here OCH3 group has +R effect, which is greater than -I it has also, but as the +R effect is more greater, so donating groups decreases the acidity, withdrawing group increases the acidity. So as NO2 group has -I -R both, that is why it is the highest acidic, and as it has a +R group effect, that is why it will be less acidic. So this orthonitrophenol is more acidic because it has -I -R both. Phenol can act as a phenol is an acid, but it does not react sodium bicarbonate. Actually, this is also very good to react, very good question, that why phenol is an acid but does not react to sodium bicarbonate. Actually, sodium bicarbonate normally react to the acid, but phenol is acid but it does not react sodium bicarbonate. Why the reason is that phenol, when react to sodium bicarbonate, it called form carbonic acid H2CO3, which is stronger than phenol. That is why reaction does not happen. See that if phenol, it is a phenol, and the NH CO3 is reacting, so it is forming ONA and H2CO3. This H2CO3 is strong than phenol. So as because it has become strong and it is weak, so it cannot go for the further reaction. That is why phenol is acidic, but it does not react with sodium bicarbonate. So normally all acid react with sodium bicarbonate, but phenol is acidic, but it does not react because carbonic acid is formed, which is stronger acid than phenol. That is why it does not react. Next, why phenol is more acidic than why phenols are more acidic than alcohol? Give example. Phenols are more acidic than alcohol because phenol, after losing the H plus, it forms phenoxide ion, which is resonance stabilized, but alcohols are not. That is why phenols are more acidic. Next question is there. Next question. Arrange water, ethanol, and phenol in the increasing order of acidity. Just now I told phenol is more acidic because it will form phenoxide and which is resonance stabilized. Number one. Then it is water and then ethanol. Why ethanol is in the last? Because ethanol is, you have CH3, CH2OH group, and CH2OH, CH2 has a plus I effect. Plus I effect decreases the acidity, so that's why it is in the last. So water will be in the before of that, then because ethanol has CH3, CH2, which has a plus I effect. That is why it has a last. Next is propene treated with the next. Give the equation. Propene treated with the B2H6 and H2O2OH minus. This is a hydrobolation reaction. Hydrobolation reaction follows the anti-Markovnikov rule. So OH part will be, as because you are adding B2H6 and H2O2OH minus, so it will go anti-Markovnikov. Anti-Markovnikov means OH will go to the carbon which contain a more number of hydrogen. H will come to that carbon which containing less number of hydrogen. So OH will go over here with respect to double bond. Here you can see contain more number of hydrogen. So OH will go over here and H will be go over here. Normally Markovnikov, OH negative charge will go to that carbon which contain less number of hydrogen. Okay, but hydrobolation follow anti-Markovnikov, that will be opposite. Negative part will go to that carbon which contain more number of. So here water is there, so water means H plus OH minus, so OH minus will go to the more carbon number of hydrogen and H plus will be the in less number of hydrogen. Tertiary butyl alcohol treated with copper 300 degree. Very important question. This is a tertiary butyl alcohol. This is the format is tertiary butyl. This is tertiary butyl format, and alcohol is OH. If it is chloride, then Cl, like that. So it is a tertiary butyl alcohol. You are treating with the copper 300 degree centigrade. So 3 degree alcohol does not able to oxidize properly. That is why it will go for elimination. So OH taking the hydrogen from the side carbon, making the double bond, and water out. So OH taking the hydrogen from the side carbon, water is eliminated, making the double bond. So those are the all revision questions of alcohol phenol.